Anyway, welcome. So what we're going to do right now is I'm going to create a series of videos that are going to cover the Algebra 1 Common Core curriculum, and it's going to prepare you, or actually it's going to leave you better prepared or prepared beyond the Common Core, to take the Common Core Algebra Regents, okay? So I'm going to get started. I'm going to start from scratch, okay? From the beginning, from the core. That's it, right? Oh, okay. So we're going to start with adding and subtracting fractions. So what we're going to do is we're going to look at a couple of fractions and see how do we add them and subtract them. Now, before we do that, I want to review reducing fractions. So when you're going to reduce a fraction, okay? Let me see this thing right? No, it doesn't right. All right. Let me see this one right. No, it doesn't right. Let me see. This one right. Okay. So let's say we have the fraction 9/6, and we want to reduce it to its simplest form. So what we do is we are going to find a number by which both numerator and denominator can be divided by. So in this case, let's see if I can do division by 2. Can 9 be divided by 2? No. 6 can, but 9 couldn't, so you can't reduce it because you have to be able to do top and bottom. Let's try 3. Can 9 be divided by 3? Well, 9 divided by 3 is 3. Okay? Now, can 6 be divided by 3? Of course it can. 6 divided by 3 is 2. And now, this is your fraction in simplest form. And why do I say simplest form? Because if I try to reduce this, the lowest number I can divide by is 2/2. Okay? But I cannot divide 3 by 2. So I can divide 3 by 3, but I cannot divide 2 by 3. So, I'm going to show you something. Something is bothering me right now. No, get off here. Get over here. Yeah, yes, that's you. Goodbye. Okay, nope, you're not getting this. Okay, now let's try B. It says 14/56. Well, let's see. 14 is an even number. Can it be divided by 2? Now, Becker, why can't you divide by 1? Well, if I divide by 1, they won't change ever because anything divided by 1 is itself. So then I have to start with 2. So remember, you're dividing top and bottom. Now, why do you divide top and bottom by the same? Because you want to keep the fraction the same. Now, I'm going to say this and it might sound weird to you. You are actually dividing by 1. What? Yes. For example, watch this. Can I divide 14 by 2? Yes. And I get 7, right? Let me put it over here. 7. Can I divide 26 by 2? Well, 26 divided by 2 is what? Sorry, not 26. 56. 56 divided by 2 is 28. Okay? Now, this is what I divided by. I divided by 2/2. That's what I divided by. I divided this by 2 and this by 2. And look, 2/2 is nothing more than a fancy version of the number 1. Like 3/3, fancy version of number 1. 4/4, because 4 divided by 4 is 1. 5 divided by 5 is 1. And you know what I'm saying? So then, is this in simplest form? Let's check. 7 is a prime number. A prime number is a number that can only be divided by two numbers, two different numbers, itself and 1. So you may be asking, is 1 a prime number? No, 1 is not a prime number because it has to be divisible by two different numbers, itself and 1. And 1 and itself are the same thing, so no, they're not two different numbers. Anyways, going back to this. This is a prime number, so it can only be divided by 7. So then, I look at the bottom and I said, can 28 be divided by 7? 7 times 4 is 28. Oh my God, yes, it can be divided by 7. So then, when I divide, look, and I'm dividing by a fancy version of 1. 7/7. So this is a fancy version of 1. 7 divided by 7 is 1. So if I divide this by 7, I get 1. If I divide 28 by 7, I get 4. Make sense? Okay then. So 1/4 is the simplest form of 14/56. Okay. Let me see if I can make this a little larger. Yeah, okay, that's it. So, Kobe, leave me alone. Alright, 25/100. 25/100. You don't need to see my face, you need to see the problem. So 25/100. How do I simplify this? Well, can I divide by 5? Yes. This divided by 5 is 5. Can I divide this by 5? Yes. So 25 divided by 5 is 5. 100 divided by 5 is 20. Can I reduce this anymore? Yes. 5 divided by 5 is 1. 20 divided by 5 is 4. So this is 1/4. Nice, right? Alright, wait. Whoop, got you. For example, how do you add or subtract fractions that contain the same denominator? Well, if they have the same denominator, that means that they are part of the same thing. Okay? So all you have to do is put together the parts and you get the total. In other words, to add, and you might want to take notes, to add fractions containing the same denominator, add the numerator and copy the denominator. Okay, do me a favor and change that -2/2 into a +2/2 because I forgot to change it. Now we want our fractions to be in simplest form. So what we want to do is we want to reduce. Well, we already went through the reducing part. And remember, let's try to see if they both divisible by 2. So can 6 be divided by 2? Yes. Can 2 be divided by 2? Yes. Which is 1. So our final answer is 3/1. Now 3/1 is what we call a fraction, a rational number. 3/1 can be simplified as, or sorry, not simplified, but rewritten as 3. Got it? Alright then. This one, look, same denominator, yes, so 7 plus 4, 11, plus 3, 14. So it's 14/5. Do me a favor and also change that -3/5 to +3/5. So, let me see now. Let me just move a little bit. Okay, you could do it, Becca. You're nice. Alright, so let's see now. Do they have the same denominator? No, they don't have the same denominator. But then guess what? We're going to make them have the same denominator. So let's see now. How can I make these two, right here, these two denominators equivalent? Well, look at the times tables. On the times tables, tell me where is the first number that when you start multiplying on the times tables, 2 times 1, 2 times 2, 2 times 3, 2 times 4, and 3 times 1, 3 times 2, 3 times 3, where is the first common number that they have? Well, let's see. This is a quick example. So I have the 2 and I have the 3. So let's start with the times tables. 2 times 1 is 2. 2 times 2, 4. 2 times 3, 6. 2 times 4, 8. 3 times 1, 3. I'm sorry. 3 times 1 is 3. 3 times 2 is 6. 6. 3 times 3 is 9. 3 times 4 is 12. And I can go on. I know that 2 times 6 is 12. I know that 3 times 4 is 12. They both have 12 in common. But that's not the idea here. The idea is to have the closest, the smallest number that they have in common on the times tables. So let's see. 2 times 3 is 6. 3 times 2 is 6. Aha, I found it. So that means that I can make these two denominators 6's. What is the process? Well, the process is as follows. By what do I need to multiply the 2 to become a 6? By 3. Okay, so then what happens is that you gotta keep the fraction the same. So you're going to multiply by a fancier version of the number 1. 2 times 3 is 6, right? So that means that what you did to the bottom, you also have to do to the top. So let's see. When I multiply this by 3 over 3, I get 9 over 6. I multiply this by 3, so I have to multiply this by 3. Now let's go on to the next fraction. I need to make these 3 a 6 because that's what they have in common. So 3 times what is 6? Right, 2. So I need to multiply the 3 by 2. But then if I do that, then I gotta do it to the top. Okay? So plus, and then 3 times 2 is 6. 4 times 2 is 8. And now they have the same denominator. That means that I only need to add the top. 9 plus 8 is 17. So my final answer is 17 over 6. Beautiful? Okay, let's try it with this one. So I have 4, 2, and 8. Talk to me, baby, talk to me. Where is the first number that you see these 3 numbers, having in common on the times tables? Well, let's see. 4, okay, definitely is not 2, because I have an 8 over here. Definitely is not 4, because I have an 8 over here. And I don't know if it could be 8, the common denominator. So what I have to do is look at the times tables. Let's see. 4 times 1 is 4, 4 times 2 is 8. Oh, okay, 2 numbers in common. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. Oh, I can make all of them 8. Oh, yes! So then, watch the transformation. Something magical is happening here. To get this to a number 8, I need to multiply by 2. So I gotta do the same thing to top and bottom. So let's see. 4 times 2 is 8. 3 times 2 is 6. Plus. How do I make this 2 and 8? You gotta multiply by 4. So 2 times 4 is 8. And then 3 times 4 is 12. So far so good. And now guess what? I don't have to do anything to this 3 over 8 because the denominator is already 8. So plus 3 over 8. They are all over 8 now, and now all I have to do is add the top, because that's how you add fractions with the same denominator. So 8, 8, 8, so then 6 plus 12 is 18, plus 3 is 21. Final answer, 21 over 8. Then we could try to simplify. How? Well, see what can I divide both top and bottom by to see if I can reduce it. Can I divide by 2? No. Yes. Okay, so it cannot be done. Can I divide by 3? Yes. Can I divide by 3? No. Can I divide by 4? No. Can I divide by 4? Yes. Can I divide by 5? No. By 5? No. 6? No. 6? No. 7? No. 7? No. 8? No. 8? Yes. I reached 8 already. So basically, this is the simplest form of that fraction. I cannot reduce any more. And that's it. Same denominator? Yes. So then add the top. Can I be reduced? You could try it. I already showed you how. You could try it. Alright. Same denominator? No. So what is the common denominator? Well, let's see. We'll get back to this. Let's finish this first. Same denominator? Yes. So 2 plus 3, 5, plus 5, 10 over 7. Same denominator? Yes. So then 1 plus 4 is 5, plus 13 is 18. And that's what you get. Now let's go on to the ones that have different denominators. Same denominator? No. Can I make them have the same denominator? Yes. And this time, I am not going to start from scratch. I'm not going to start explaining. I already did that. So if you need to, if you need an explanation again, you just rewind it and we're good. So 6, 3, and 2. What do they have in common on the times tables? That they all, when multiplied by a number, you can always get 6. Look, 2 times 3 is 6. 3 times 2, 6. 6 times 1 is 6. So they all have 6 in common. So let me turn this into equivalent fractions with the same denominator. This one I don't have to touch because it's already a 6. So 3 over 6. This one I gotta turn into a 6. So 3 times 2 is 6. I multiply by 2, so I have to multiply by 2. This one, it's 5. This one is 2. How can I turn that 2 into an 8? I gotta multiply by 4. So 5 times 4 is 20. 2 times 4 is 8. Oh my God, what did I do? Did I make a mistake? Yes, I made a mistake. So what? I'm supposed to turn it into a 6. So I just have to multiply by 3. Okay, so by 3. 5 times 3 is 15. So I'm gonna look. This is a 15, okay? And now 2 times 3 is 6. Cool. Now they all have the same denominator. And now let's see. 3 plus 8 is 11. 11 plus 15 is what? 26. 26 over 6. Can it be simplified? Yes, it can be simplified. Am I going to do it for you? No. But just know that, can you divide this by 2? Can you divide this by 2? If your answer is yes for both of them, then guess what? You can simplify it. Okay. Let me see now. Okay, let's see. 3 and 4, they have 12 in common. But this one doesn't have 12. 6 also has 12 in common. Oh my God. Okay, maybe 30. 3 times 10 is 30, but 4 times 10 is 4 times anything is not 30. Okay. You know what? How about 60? Can I multiply by something by 3 and get 60? 20. Okay. So let's see now. So this one, I'm just gonna put it over here. So I have, I'm going to multiply this by 20 over 20 to get 60. Can I multiply 4 by something to get 60? Yes. 15 over 15. Can I multiply 5 by something and get 60? Yes. 12 over 12. And can I multiply 6 by something to get 60? Yes. 10 over 10. I hope you understand what I'm doing right now. So that will make all these denominators 60. So let's go right ahead and do it. Okay, if I multiply by 20 over 20, I'm going to end up with 20 over 60. Correct? 1 times 20, 3 times 20. Okay, and now when I multiply this by 15, and that's plus, right? 15 times 2 is 30 over 15 times 4 is 60. Plus, okay, plus 5 times 12 is 60, 3 times 12 is 36, so this is 36 over 60. And last but not least, multiplying 10 by 10 over 10, I get this to be 40 over 60. And now I'm ready to add. So let's see, they have the same denominator. So 20 plus 30, 50. Okay? 50. 36 plus 40 is 76. So 50 plus 76 is what? 126 over 60. Can I reduce this? Sure. What's half of 126? 63. What's half of 60? 30. And that is your simplest form. I don't think you could do anything else with that. Oh no, actually oh no, you can. Let's see if I can divide these two by 3. So 63 divided by 3 is 21. And 30 divided by 3 is 10. So yes, I get 21 over 10, and that's it. I don't think you can do anything else. It don't matter, it don't matter, it don't matter. Beker's test. I study that. Regents exam. I own that. Oh! Oh, sorry. Okay. So that was corny, of course. Today's learning intention number 2: multiplying and dividing fractions. This is what you're supposed to be able to do at the end of this lesson. So pay close attention. If you don't understand, rewind it, okay? Cool. This is for you, family. Let's go. So multiplying and dividing fractions. When you multiply fractions, you go like this. Psh, numerators. Psh, denominators. You multiply the numerators and you multiply the denominators, and that is your final fraction. If you need to reduce it, reduce it. If not, mwah. So let's see. When you multiply fractions, it does not matter whether they have the same denominator or don't. Look. Whether they have it or not. Look. 3 times 3 is 9. Times 2 is 18. So you got 18 over, and guess what? You're also going to multiply the denominators. So you have 3 times 4, 12, times 3, 36. And that's it. Now, can I reduce that? Sure. Now, using my superior intellect, I'm not going to divide by 2 and get 9 over 18. Then I'm not going to divide by 3 to get something. Then I'm not going to divide by 2. No. Look. Remember, work smart, not hard. So, is 18 half of 36? Yes. So all I have to do is divide everything by 18 and I get 1/2. Good. Okay. Let's try this one. 7 times 6 is 42. And 42 times 3 is what? 126. See that? Over. Yeah. You see, I put this as a way to try to deceive you. But you have to understand, we're multiplying. So we're not copying the denominator. No, we're multiplying just the same way we did over here. So 2 times 2 is 4, times 2 is 8, and we get 26 over 8. Okay? Now, can that be reduced? I don't know, but we're gonna find out. So this is the same thing as, and I'm gonna put it over here. Okay? 63 over 4. Okay? If you divide by 2 on both, then you get that. Now, yo, Bex, how the hell you do that? Like, you awesome. Nah. Look, basically this is what I did. Let me see if I can do that. So what I did was I pressed on this calculator, right, the TI-84 plus CE, I pressed alpha y equals. And that gave me a fraction. I don't know if you could see it. But, alright, so let's see now. And then I put 126 over 8. See that? Let me see. And then I press enter. And I got my fraction, which is 63 over 4. That's basically what I did. Okay? Good. Alright, so let me see now. What in the world is this? Oh, I don't know. Oh well. I don't know, select the subject, whatever. It don't matter. Alright, so let's continue with the lesson. Alright, so 6304, and now let's go to example number 2, which basically, it's easy. 3 times 4 is 12, 4 times 3 is 12, 12 divided by 12 is 1, and that's it. How about this one? 12 times 1 is 12, times 3 is 36, 5 times 2 is 10, times 8 is 80. I am not going to reduce it for you. You can reduce it yourself. You already know how to. So this is, I'm not teaching you how to reduce fractions. I'm teaching you how to multiply and divide fractions. So that's how you multiply fractions. To divide these fractions, always keep the original fraction to the left the same. So it's going to be 3 over 2, right? You're going to change the multiplication sign or symbol. Oh my God, I keep saying multiplication. You're going to change the division sign to multiplication. And then you are going to flip the fraction. See that? That's basically it. That's how you divide fractions. Now, what do you get? You get 3 times 5 is 15. 2 times 8 is, 2 times 4 is 8. Ugly 8, but hey, it's there. And this is your final answer. Okay then. But Bex, what happens when, because I know about the keep, change, flip, but what happens when you have a more complex division? Let's say you have, okay, let's call this B. 2 over 3 divided by 1/2 divided by 5 over 4. Let's say that. Okay? What happens then? Well, the same concept applies. You're going to keep the first fraction the same. You're going to change this to multiplication. You're going to use, and now I'm going to use academic vocabulary, so it's not just flipping. You are going to use the reciprocal of 1 over 2. The reciprocal of 1 over 2 is 2 over 1. Okay? Guess what? You have another division here. So you're going to do the same thing. You're going to change that to multiplication, and you're going to switch this. You're going to use the reciprocal. See that? That was easy. Not bad, right? So then, now that everything is multiplication, we just go straight forward. 2 times 2, 4, times 4, 16. 3 times 1, 3, times 5, 15. And voila. That is your answer. That's basically what you get. Let's do another problem. Let's say example, okay, let's have this example. Let's say you have 2 over 3 divided by 3 over 3 multiplied by 2 over 3. Okay? So let's see how we tackle this problem. I have a division and I have a multiplication. So let's start. Remember, when you have division and multiplication, you work from left to right. Okay? It doesn't matter which one. So let's try. So 2 over 3 stays the same. Change this to multiplication. Believe it or not, what is the reciprocal of 3 over 3? Hello, 3 over 3 is 3 over 3, whether you flip it or not. So it stays the same. Oh, okay. So 3 over 3. And then do I need to change anything here? Huh? Do I need to change? It's multiplication. There's nothing to change. Guess what? I don't flip anything because there is nothing to change. Multiplication stay the same. And now, 2 times 3 is 6, times 2 is 12. 3 times 3 times 3 is 3 to the third power, that's 27. And now, can I simplify 12 over 27? Well, can I divide by 2? Yes. Can I divide by 2? Nah. Can I divide by 3? Yes. Can I divide by 3? Yes. Okay, so 12 divided by 3 is 4. 27 divided by 3 is 9. So that's what you get? Yes. Okay, cool then. So, final answer, 4 over 9. Let's do one more problem. So let's flip this. Okay. So we're still on division. Remember, we're dividing and multiplying fractions. So let's see now. I have another example. And I have 7 over 4 divided by 3 over 4 divided by 2 over 4. Okay? So this becomes 7 over 4. We don't change that. This is a division. We're going to change it to multiplication. And we use the reciprocal here. See, we flip. Another division. Well, switch it to multiplication and you know what to do. See that? Not bad, right? Not too shabby. Alright, 7 times 4 is 28, right? Now 28, right? 28 times 4. 28 times 4 is some number. 112. Let's go with the bottom. 4 times 3 is 12, times 2 is 24. Okay? Can this be simplified? You bet it can. Can I divide this by 2? Yes. Can I divide this by 2? Yes. And then you continue and you simplify it. The idea here is not to teach you how to simplify, but to teach you how to divide fractions. Okay. Now, or you know what? Okay, what's half of 112? 56. What's half of 24? 12. Can you take half of 56? Yes. What is it? Is it 28? And half of 12 is 6. Can you take half of 28? Yes. Can you take half of 6? And so on and so forth. I'm really not into the reduction right now, the simplification. Yeah! Oh my god, this is distracting. Alright, so today we're going with the learning intention number 3, okay? So basically, we're going to be adding, subtracting, multiplying, and dividing sign numbers, okay? So, well, students will be able to, blah, 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 blah. Now, these are important concepts, okay? Scaffold. When we add, okay, sign numbers, what are you doing? Bye. Jesus Christ. Bye. Bye, bye, bye.
I'm getting the video.
You didn't know. Okay, so important concepts. When you add a negative number, it's like you're doing subtraction. Okay? A plus negative b is the same thing as a minus b. Okay? For example, 8 plus negative 4 will be the same thing as ugly 8 minus 4. As simple as that. Which is basically 4. Now you have to take into account, I hate to see two signs together like this. So what I do is whenever you have two signs together with no numbers in between, multiply the signs. Multiply the signs and you're gonna end up with positive times negative is negative. So look, negative. So now, when this symbol is between numbers, it's read as a minus. If it's read at the beginning of a number, to the left of the number, it's negative. That's the difference. Now in the calculator there is a negative and there is a minus button, so you have to make, the difference. Anyways, so a minus 4 is 4. As simple as that. Guess what? A number minus a positive number, when you take away, is the same thing as if you're adding the negative, okay? Adding the negative or subtracting the positive of a number is the same thing. You still get a minus b, a number minus the other, okay? Look, negative times positive is negative, so this is the same thing as having negative, let me see if I can write it down here. I can barely write in my hand. Negative 8 minus 2, because these two signs turn into a negative because you multiply them. Alright, so negative 8 minus 2, that's negative 10. Two ways of doing it. You could use the calculator or you could use your common sense. If you lost 8 pounds and then you lose 2 more pounds, you lost a total of 10 pounds. Or if the temperature is negative 8 degrees and it goes down 2 more degrees, then you have negative 10 degrees. Alright? Don't worry, we're gonna look at the number line. Look, let me do negative 8 minus 2. So this is the number line right here. Right? So this is 0, right? Negative 1, negative 2, negative 3, negative 4. Jesus Christ. Negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. Okay? So I have this. So it says negative 8 minus 2. So I am going to go to negative 8 right here. And minus 2 says go to the left. It doesn't say plus 2. So minus 2, I have to move to the left. So negative 8 minus 2, minus 1 minus 2. And you see where it falls? At negative 10. So now that's another thing that you could say that will help you. You could always use the number line if you need to. What's up? You need to go there? Go.
Yeah.
Alright, so...
Lucky pencil.
Yeah, lucky pencil, bye. Alright, so let's try this one. Negative 3 plus negative 4. Okay, if you're adding two negative numbers, you get that. But remember, negative 3 plus negative 4 is the same thing as negative 3. And I hate to see two signs together, so I am going to multiply them. And look, positive times negative is negative. Because when you have two different signs and you're multiplying them, your result is going to be negative. If you have the same sign multiplying, then it's going to be positive. Like negative times negative is positive. Positive times positive is positive. Okay? Okay, okay. What about this one? Negative 4 plus negative 5 is the same thing as what? As negative 4 minus 5. See that? Now, remember, when you're adding two numbers that are negative, or here, do they have the same sign? Yes, look, negative 4, negative 5, negative 9. Alright? Cool. Let's see what else is in this little thingy. Okay. So now we have rules, right? Rules for multiplying sign numbers. This is something that you must have in mind. Always keep in mind, okay? This is gonna save you. Or the calculator could tell you. Okay, look, positive times positive, positive. Negative times negative, positive. Negative times positive, negative. Positive times negative, negative. The same thing goes for division. Positive divided by positive is positive. Negative divided by negative is positive. Positive divided by negative, negative. Negative divided by positive, negative. If you cannot remember mathematical vocabulary, then remember this. The friend of my friend is my friend. The enemy of my enemy, my friend. The enemy of my friend, my enemy. The friend of my enemy, my enemy. And the same thing goes for division. These are things that I cannot really teach you in terms of like make you understand, because you have to remember them. If you can remember this, then you are safe, because when we start solving equations, it's something that you might need. Anyways, let's see what's up. Independent practice activity on lesson number 3. Remember, learning intention number 3. Now, if we talk about vocabulary in here, what will be some of the terms that you might want to write down as your vocabulary? Negative, positive, signed numbers, multiplication, division, addition, subtraction, okay? So negative 3 plus 4. You owe $3 and you add $4 to your, well, no, actually you add 4, meaning you pay 4. So if you owe 3 but you pay 4, you got $1 remaining. Or think of it as a bank account. You are at minus 3, okay? You have a balance of negative $3 in your account. You deposit 4, then now you have 1. Look here, negative 3 plus negative 3. This is the same thing as 3 minus 3. Sorry, negative 3 minus negative 3. Again, mistake. Negative 3 minus 3. The two numbers have the same sign, so you're going to add them. Or think on the number line. On the number line, let's say you have the number line right here. So this is 0 and this is, let me see, this is 0 and this is 1, so this is negative 3. You are at negative 3, that's where you start. And this is a command to go to the left, okay, of negative 3. So this is a command to go left 3 units. So I'm gonna go to the left, 1, 2, 3 units. So this is negative 4, this is negative 5, this is negative 6. Number line. I know you're beyond that and you already know how to do this, but just saying, you know. Okay. Okay, here. Negative 3 plus positive 3. That's so corny. You know why? Because like you don't want to have plus positive. And anyway, you have 2 signs there. So you know what? Take the 2 signs and multiply them. What do you end up with? You end up with negative 3 plus 3. So you are at negative 3 and you have a command to go to the right, because this is a plus, you are adding. So I'm going to go to the right 3 units. Look at what happens if I go to the right 3 units. 1, 2, 3. I go to 0. So negative 3 plus 3 is 0. But anyway, it's not rocket science. If I read it backwards, let's read it backwards. 3 minus 3. 3 minus 3. 3 minus 3. 0. 0, 0, 0. Oh, okay. Ooh, nice forehead. So here, now we're going to start with multiplication. 4 times 4 is 16. Negative times negative, positive. So positive 16. Negative, negative, negative. Let's see. Negative times negative, positive. Okay. So I have a positive here. Positive times negative, negative. Okay, cool. Now let's multiply. 3 times 2 is 6. Times 5, 30. Okay? Do we have more examples? Yes. What is the value of sa-na-na-na? No, no. Okay, can we see this? Yes, we can see it. Well, I really have no idea. I'm gonna have to use the calculator. Oh, this is gonna save you. Trust me, you need to get this one. TI 84 plus CE. So, let's see now. What is the value of 4 times 4 minus 3 times 3 minus 16 divided by 4. According to the so-called order of operations, PEMDAS, we should do parentheses, exponents, we do multiplication and division. It doesn't mean that you're going to do multiplication first and division later, or division first. No, you could do whichever, as long as you go from left to right. So let's see how it goes. There is a multiplication here, right? It's like if you have parentheses, okay? Then minus 3 times 3. See that? Minus 16 divided by 4. That's how you do it. So what do I get? 4 times 4? 16. Minus 3 times 3? 9. Minus 16 divided by 4? 4. So let's see now. 16 minus 9 is 7. Minus 4, 3. Final answer, 3! Okay. Negative 8 divided by 24. Negative 8 over 24. That's a fraction, and I know I'm going to get a decimal if I try to divide it. I don't want to be dealing with decimals, so basically, I'm just going to simplify that, right? And we already did that in lesson 1 or 2. So let's see now. First, negative divided by positive is negative. Can 24 be divided by 8? Yes. Can 8 be divided by 8? Yes. Negative 1/3? Yes. Now here I have an addition of fractions. Well, do they have the same denominator? Yes. Negative 1, okay, plus 5 is negative 4. Is 4. See that? And 4 divided by 2 is 2. That's it. Okay. Now, do me a favor. You need to try this on your own, and then you pause the video, and then we could check to see if you got the right answer or not. Okay, negative 3 plus 1/2. I could tell you right now, negative 3 is larger than 1/2. And 3 is larger than 1/2. 1/2 is 0.5. So I'm going to try to tweak it a little bit. Negative 3 plus 0.5 is negative 2.5. Now let's think about money. This is $2.50. $2.50. That is the same thing as 5 over 2. Because if you have $5 and you divide it by 2 between two people, you're gonna end up with $2.50. So this is the same thing as negative 5 over 2. Now if we're doing it the way we always do it, then we're gonna turn this into a fraction. So we're gonna have negative 3 over 1, okay, plus 1/2. I need a common denominator right here. Well, where on the times tables do the 1 and the 2 meet? Well, 1 times 2 is 2, and 2 times 1 is 2. So all I have to do is, the common denominator is 2. So I need to turn this into a 2. Okay. So how do I turn this one into a 2? Multiply by 2 over 2, right? So this turns into negative 6 over 2 plus 1/2. Okay? Now they have the same denominator. Negative 6 plus 1 is negative 5. Same thing as what we got right here. Right? Cool then. Alright, so this is a multiplication, plain and simple. When we multiply, we go straight through, right? So 3 times 3, oh no, 3 times negative 3, oh damn. Negative 9, 2 times 4, 8. Ouch. Alright, so now why is it, this is boring. Okay, if I don't fall asleep, that means that we're Gucci. Alright, 1/2 divided by negative 1/2. A number divided by itself is 1. And a number divided by its opposite is negative 1. So, if I was to do it the regular way, I would write 1/2, change the division to multiplication, and do the reciprocal of this number. So, flip the fraction, correct? And then I end up with 1 times negative 2 is negative 2, over 2 times 1 is 2, 2 divided by 2 is 1, negative divided by positive is negative, and voila, bada bing, bada boom, we got it. Remember, you're supposed to try this first, and then you could put it, alright? Okay, here, a subtraction of fractions. Different denominators means I have to find the common denominator. Well, where on the times tables do 3 and 2 what? 3 times what and 2 times what give you exactly the same number? Well, 3 times 2 is 6, 2 times 3 is 6. So I know that 6 is the LCD, the lowest common denominator, the lowest common denominator, or the least common multiple, or the minimum common multiple. All those, I mean, they mean the same thing. So how do I turn this into a 6? I multiply by 2, right? So multiply by 2 over 2. So I get negative 2 over 6. Minus, how do I turn this into a 6? Multiply by 3. So 3 over 3. So I get and now negative 2 over 6 minus 3 over 6, they both have the same sign. When you're adding numbers that have the same sign, you add the numbers and keep the sign. So this is negative 5 over 6.